Hi, I'm Lindy, a Terra representative.
And I'm Evan, Director of Business Development at Terra.
We're so happy to be here today to answer your questions.
Today we'll be answering questions on cleanroom design.
This list of frequently asked questions from Terra's customers can guide our conversation.
Excellent. There are many factors to consider before owning and operating a cleanroom. Let's take turns answering our customers' questions. A standard lab may appear clean, but it's not as clean as it looks. Cleanrooms are isolated areas equipped with ceiling-mounted filtration systems designed to remove pollutants from the air.
When you mention pollutants, do you mean dust?
Dust is one pollutant, but the filtration system also removes airborne particles, microbes, and other contaminants.
Contaminants in the airstream cannot be removed through strict cleaning protocols. If the environment in your work zone is contaminated, you are likely to experience inaccurate test results, QC failures, and possibly product recalls. Your standard lab doesn't include controls to alert you of contamination, so you may not find out until it's too late.
HEPA filters capture virtually all particles larger than 0.5 microns in diameter. This includes dust, bacteria, VOCs, and frankly, most airborne contaminants. ULPA filters are designed to catch particles as small as 0.17 microns in diameter, including viruses and tobacco smoke. For most applications, HEPA filters are optimal.
When choosing a fan filter unit, there are many factors to consider. If power consumption is a concern, smart FFUs with EC motors reduce energy costs by up to 60%. For certified spaces demanding regular filter changes, room-side replaceable models allow for easy filter replacement without sacrificing cleanroom integrity. For microscopy labs, low vibration units are the gold standard. Other factors to consider include noise level, overhead makeup airspace, and facility voltage.
Although the filtration system is the first line of defense against cleanroom contamination, a secondary defense mechanism is air circulation. Cleanrooms are designed to maintain uniform, unidirectional laminar airflow, filtered airflows from the FFUs across the most critical work zones before diverting toward exit points. Laminar airflow protects the work zones from contamination caused by second-pass air, or the particle swirling effect. To achieve complete laminarity, facilities will install false or raised perforated flooring with an air plenum installed underneath.
Cleanrooms maintain a higher internal pressure, or positive pressure, as compared to adjacent spaces. The positive pressure is maintained by the constant air influx provided by the motorized fan filter units. We know from inflating a tire or a balloon that passive air flows from an area of high pressure toward an area of low pressure. Cleanrooms are designed in the same manner, so dirty air will not seep into the cleanroom through an open door or exhaust grate.
Cleanrooms include a broad range of atmospheric controls. Depending on your application, you may specify controls for static discharge, temperature, pressure, and moisture.
While certain products like microelectronics and medical devices are sensitive to static discharge, other products like bulk chemicals and resins degrade in the presence of moisture. Humid environments promote mold and mildew growth, which may contaminate cell cultures. Pharmaceutical cleanrooms commonly include particle counting systems, which sound audible alarms if levels are too high. Static control is accomplished through the use of ionizing bars and static dissipating plastic surfaces like PVC. The cleanroom temperature and humidity are controlled through integration with facility-wide HVAC systems or standalone AC modules appended to the room. Moisture is controlled through desiccant-based air dryers.
The International Standards Organization, or ISO, categorizes cleanrooms based upon the quantity of particles per cubic foot of air. The cleanest classification, ISO 3, denotes an environment containing 1 particle per cubic foot. The least rigorous classification, ISO 8, specifies an atmosphere containing 10,000 particles per cubic foot. Check with your compliance officer to confirm which ISO class is appropriate for your application. The ISO classification is validated by particle measurements performed with a benchtop or handheld particle counter. Traditionally, particle counts are performed 6 inches underneath the filter face, but certain standards require particle fallout tests, which are performed at desk height. For additional information, please visit Terra's website or call the number on the screen to discuss your requirements with Terra's technical sales team.
Stay tuned for more videos in Terra's educational series on critical environments. In our next video, we'll discuss the criteria for selecting the ideal cleanroom for your application.